Good morning and thanks for being here. It is Data Converter, ADC and DAC product understanding for characterization. Listen first.
Almost heaven, West Virginia, Blue Ridge Mountains, Shenandoah River. Life is old there, older than the tree.
What a melodious song it is, isn't it? I want to tell you, good music is the output of high resolution good DAC, digital to analog converter, which is a data converter. My presentation is related to this. What is this? These two boxes seem like some electrical products or panels. Yes, right side box is an industrial choke enclosure. It contains industrial transformer big coil which deals with the thousands of volts. Left side box is looking the same, but it is not. It is the first commercially offered electronics analog to digital converter. I am telling here a little bit history of data converter development. Bernard and Gordon patented and designed vacuum tube based electronics 11-bit analog to digital converter. Yes, size was big, consumption was high and weighing around 68 kilograms. Costly, $8,000 to $9,000. Today, we are having ADC and DAC up to 16-bit resolution, small in size, low in power consumption, and cost is reduced by around 400 times. So it is around $10 to 30. Weight only 10 grams. Today the silicon chips are being designed using a very thin device named as CMOS transistors. Why do we need data converters? This analog world has the various analog signals which we used for ourselves. For example, sound, light, electricity, gravitational force, heat, etc. These utilization of these analog signals which are available in the environment use or requires processing. Digital signal processing is the best. So this flow graph is showing these analog signals which are available in this world. How are these processed? First, analog physical signals are converted into electrical signal by sensors, then to digital signal by ADC. We do the digital signal processing in laptop or computer microprocessor. Then DAC converts it into analog electrical signal and then analog signal by actuator. Let's see it with an example of sound. Sound is converted to electrical signal by microphone, which is the sensor, then digital signal by ADC. We do the digital signal processing or audio signal processing for echo effect or adjusting the tempo and pitch of the sound. This digital data converted back into the analog signal, and these analog electrical signals are converted into sound or music by speaker. And this processed music is like as we listen at the start of this presentation. The ADC and DAC are used in many applications, like in this phone as shown in the slide. How does data converter work? First, the analog signal are divided into many levels, and these levels depends on the number of resolution. Suppose n-bit resolution data converter will have the 2 raised to the power n number of levels. The approximated signal value of these levels are called digital codes. DAC gives the output, analog output, depending on this digital code, which is the interpolated value. This red one is the analog natural signal, and the converted analog signal from the DAC is the green one. So the converted analog signal is not exactly the same as the input. How good our data converters are decided by their specifications, and these specifications are mentioned as there are some major specifications like resolution, differential nonlinearity DNL, integral nonlinearity INL, signal to noise ratio SNR, signal to noise and distortion ratio SNDR, and effective number of bits INO. Let's see it one by one. Resolution related to the number of levels in which analog signal is divided, or in the DAC, number of digital codes which represents the signal. As mentioned in the previous slide, n bit resolution will have the 2 raised to the power n levels. For example, 10 bit data converter will have a 2 raised to the power 10, that is equal to 1024. Value of unit width of these levels are called LSB, least significant bit, and maximum value of the signal is called full signal range, FSR. One LSB change at the input of ADC changes the one digital code. One code change at the DAC input changes the one LSB analog output. So deviation of this behavior is called DNL. Maximum deviation of its actual transfer function from the transfer function line, which is the ideal one, is called the INL. INL at any point, actually it is the summation or integral of all the DNLs starting from minimum. What is the transfer function? Transfer function is the output behavior as a function of input signal, or whether it is voltage or current. During the conversion, there is a lot of noise in the signal. As we have seen, the converted analog signal is not the same as the input. So how less noise is with respect to signal is called the signal to noise ratio. It excludes the harmonic, distortion, and DC. What is harmonic distortion? In the noise, some components are predictive or repetitive in nature. For example, the noise which is multiple of clock frequency or signal frequency is the always predictive. So this deterministic component in the noise is called harmonic. SNDR is the total summation of random noise and deterministic noise. So it tells us the actual signal and noise behavior. Effective number of bits is the another way to represent the SNDR. The formula INO is equal to SNDR minus 1.76 divided by 6.02 is obtained by solving a mathematical equations and expressions. As it is shown here, the resolution will be the same, but effective number of bits decreases as the signal frequency increases. For example, at 10 kHz signal, the INO is 10 bit, but at 100 kHz it is less than 8 bit INO for 10 bit data converter also. So at the last, not the least, we introduced and covered the brief history of data converter development and introduction of specification like resolution, DNL, INL, SNR, SNDR, and INO. It will surely help to characterize and to debug the data converter more efficiently, and qualitative and good characterization report is very important to showcase your products in the market. Thanks for listening it patiently, and listening is the beginning of understanding. Thank you.